Hi, everyone. Good morning, good afternoon, and good evening to whichever part of the world you're joining from. Welcome to the 2021 events of Brazil's Women in Data Science. Women in Data Science started as a one-day technical conference at Stanford in November of 2015. It's now a conference with 150 plus regional events worldwide in more than 60 countries, reaching 100,000 participants annually. It consists also of a datathon, a podcast series, an education outreach program, as well as a workshop series to build your data science skills, inspiring women and girls with role model instructors. The Women in Data Science Conference of 2021 comprised of 2,000 plus attendees from 65 plus countries. It had 200 plus events, 40 plus speakers, and from 25 plus countries. Finally, it had 100,000 participants joining us online. The chapter of Women in Data Science Brazil have the ambassadors, Maya, and our team. We organize 8 talks from amazing speakers lined up for the month of March. And the community partners, as well as the platform partners for this, are DeFi. The 8 talks that I was talking about were ranging from 9th March to 1st April, where we're already at the last session now, which is on building a sentiment analysis tool for Dutch. The speaker for today, Shoera, graduated in mathematical engineering at the KU Leuven in 2018. She was mostly drawn to the courses that was about data science and ML, which is why she started working as a data scientist at Delaware. At Delaware, she was involved in some very interesting data science projects where her main focus was within the NLP domain. Exactly 1 year ago from today, she joined Radix, which is an AI consultancy. At Radix, her main role is the role of project lead, where she makes sure that all the projects that are done are translated into success for their clients. Although she mainly works as a project lead, she is still involved in projects from a technical perspective. Thank you, Shoera. The stage is all yours now.
Thank you. I will share my screen.
Yeah.
Okay. If I'm correct, you can now see the slides of the presentation.
Yes, we're able to see.
Yeah, okay. So good day, everyone. Yeah, this I will skip because I was also already introduced, but maybe I can go a little bit more in detail about Radix. So we are an artificial intelligence agency, and we help our clients empower them by using AI in their organization. And so today I will talk about a project that we have done last year in November, which was about researching how we could use Twitter sentiments, Twitter tweets to measure the sentiment of the people speaking Dutch. So the goal is to have a Dutch model that can, a model that can understand Dutch and that can categorize it in 3 categories, so positive, neutral, and negative. Where there is one specific challenge that, of course, in Belgium there are a lot of different dialects, so it also has to understand dialects, but also the language in general used in tweets. It can have more slang than just in the normal Dutch vocabulary. And then the third goal was to automate this within a flow. So this meant that we wanted to automatically take tweets from Twitter, define its sentiment, and show it on a dashboard. So this is a project that we have worked on last year, and I will present it to you today. So what I will talk about today, I will first go into the sentiment prediction model, how we selected the model and how we trained it to solve this specific problem. Then I will go a little bit more about the labeling action that we did, because of course we needed to label some tweets in order to improve the performance of the model. And then I will talk about the evaluation. So how did the model perform in the end? So as a next point, I will go into the automated flow that we set up. This will be a shorter point, but I still think that it can be interesting to also understand what other components that you need in order to have this fully automated. Then I will show you a demo of the dashboard we have built and a small section about future enhancements, because there are a lot of things that we have learned during this project, which we would take in mind if we would like to improve this And then we can end with a short Q&A section where you can ask some questions, which I will then address. So first I will start with the training, the sentiment prediction model. And the first focus here is to find a model that is a good start for the Dutch language, because in other languages there has been done a lot of research already, a lot of pre-trained models have been built which you can use, but for the Dutch language this is not always the case. There has been some studies, but it's not been studied as much as, for example, the English language. As a quick recap for the people that are not super familiar with NLP, so the basic of the problem is that we want, from the texts that we have the tweets, they consist out of text, and we want to make them into a mathematical representation, which we call word embeddings. Because of course the computer, it can only understand these numbers, it cannot understand text. How do we do this? Well, there are a lot of things you could do. One example could be to count the words in your text, and then, for example, each entry here could be how often one word occurs in a document. But this means that all words are evenly different or similar to each other. So, for example, tree and trees, for us it's the same, it's only a plural, but it's the same. But for the model it will be two totally different words. So that's why we want models that also take this semantic meaning into account. So that's why we work with transformers. So to give a short introduction of what it does. So at the learning phase, you give this model a lot of data that has already been written. For example, Wikipedia, it is full of Dutch or English, doesn't matter in which language you want to train this model. It has a lot of data where you can then just remove some words, and you train the model to predict these words that you have removed. So if we give this sentence one time to this model, it will learn that it has to answer this with fox, but of course maybe next time it will be another word, it will be the quick brown dog jumps over the lazy dog. So it learns to make like a probabilistic representation of the words, so that then at the prediction phase, if you then give these words to the model, it can predict that it could be fox, but also cat, dog, and things like that. And this is actually quite interesting, because these mathematical representations, you can also do some mathematical calculations on it. So for example, there is a relationship between how the embeddings of a city and its a country and its city, how they belong to each other. So if you know this relation for one pair, then you can actually calculate them for all of them. Another thing that this does is it also takes into account the context. So for example, the word arms, it can have two meanings for us. It can have the meaning that it's a part of your body, but it can also have the meaning like weapons. And of course, we don't want them to be represented in the same way, because they have a totally different meaning. And as you see from this picture, it shows how similar these three words are to each other. And we see that indeed arms are more similar when they are in the context of a body part than when they are in the context of a weapon part. So this is actually what we would like to achieve with our model as well. Of course, it's also possible to already train this model, because once it is trained, you can reuse it. You can send it to someone else and that person can reuse it. You don't have to, not everyone has to train this model themselves. And because of this, there is like some kind of library, the Hugging Face library, where people who have invested some time in training a model and making sure that it's good in a specific context, that other people can use this model as well. So as a first step, what we did was to look which model could we use as a starting point for our solution. For example, the here, you see that there already is actually a Twitter sentiment model which we could use. But the problem with this is that it's in English. So we don't want to use it because our data is not in English, it's in Dutch. Another example is, for example, this Japanese sentiment model. You see it is a model that was already trained to determine sentiment in Japanese. So if we would like to have a Twitter sentiment model in Japanese, this could be a good starting point. And then there is a third model that we see. It's a multilingual. This is something that has been made in the past for languages for which there is not a lot of data. What it does, it will learn from multiple languages at the same time, and by doing this you increase the data set, so it can learn more representations, and then it can understand all these languages. So this could also be a starting point to then fine-tune our Dutch on, because it already has some understanding of the Dutch language. After some research, we found out that there actually already was a model, so the Dutch RobBERT-based language model, which was developed by the people mentioned here, and they mention in their paper that there is a multilingual BERT which you could use as a basis to then fine-tune for other tasks. But in the past, it has proven that a model that is trained on one specific language, it still is better than a multilingual model. So this multilingual model, we should really only use it when we don't have a lot of data and we don't have the capacity to label any data, and we want, so that's why they spend some time in also preparing like a real Dutch model that then other people could use. So we decided to use this model definitely because in the paper it also mentions that they built a model with a classification head where they show that they have 95 accuracy for the Dutch book reviews dataset. So this shows that in a context of sentiment analysis, this model already performed well in the past. So for the people who are interested in the more technical aspects of this, so it's Roberta architecture, which then they called RobBERT in Dutch. So it uses subword tokenizer so that there are no out of vocabulary words. What is out of vocabulary? When a model has never seen a word before, it cannot understand it. It cannot do anything with it. It's just the same as people. If you hear a word that you have never heard before, you don't know what to do with it. So it's the same for a model, but the model, it will now split it up smaller words, and if it understands the smaller words, it will work with this context instead of the whole vocabulary. It makes use of 12 self-attention layers, so this is what you see here. So to explain the figure a little bit more, so we have an input which is just a sentence, and we split it up by tokenizing it. We embed it, and then there are the attention heads to then predict which these missing words should be. So that's what I explained earlier. From a mask, we want to predict which words should be there. This is then pre-trained on 39 gigabytes of Dutch text. So this model is really good at already understanding the basic Dutch vocabulary and words and how they relate to each other. Of course, in our problem, we don't want to predict a missing word. This is not the goal of our project. But what do we want to predict? We want to predict just an output in 3 classes, so positive, negative, or neutral. So therefore, we just use this to encode our text to make a mathematical representation out of it, and then we can use this mathematical representation to train a model that can predict, like a classification model. Because of this Dutch sentiment dataset that we already had, we wanted to use this because this could already help us to make a model also understand which words are important for a sentiment. But there were some problems with this dataset. It only had two categories, so not the neutral one was missing. It has other context than Twitter because, yeah, of course, in a book review, often the same kinds of words will come back. It will not be that broad of a vocabulary, while on Twitter people really talk about anything. So yeah, it's not, the context is not perfect, and it also had longer text than that you typically have in Twitter. So that's why this can only work to already pre-train the model, but it will not do well on the final classification task. So that's why we also added some labeled Dutch tweets, but we had to label them ourselves. So this is really the reason why we also wanted to use this Dutch book review data set, because yeah, labeling, it's not that easy. It takes a lot of time. It takes often a lot of work to let people do it. You have to train them to make sure that they label well. So you want to minimize the amount that you have to label. So by doing this, it was okay that we just labeled 50,000 tweets. Otherwise, it would have been more. So we decided to label 50,000 tweets. How did we define these 50,000 tweets? So first, we extracted these tweets from Twitter. We decided to take tweets from over the 5 past years and sample them from this whole period, because if we would only have taken tweets from the past year, it would have been really Corona oriented, and it would be really good maybe in understanding when a tweet about Corona is positive or not, but it's not enough context. So we wanted to use 5 years to have different angles and things like that. We don't take into account a reply or a retweet, because this is not a first-hand sentiment. It's often a sentiment on what someone else said. So we don't want to take this into account. And we also did not take into account embedded media, because often people post maybe a picture and they give good and then this picture, but we don't know what is in the picture. So we can't really grasp why this person is liking this, and we only want to focus on the text. So we don't take into account the tweets that have embedded media. Then we extracted 200,000 tweets in total, and we encoded these with a multilingual sentence encoder to compare them, and the most similar ones were then discarded. So this means that only the most unique tweets were held, because there are a lot of tweets that are automatically generated that are the same. I think one example that we saw a lot was, hey, it's your birthday, or something like that. So it's something that's automatically generated, and we don't want to label this 10,000 times or something like that. So that's why we did this. And then we also incorporated some active learning. So because we already had this pre-trained model that could classify these Dutch reviews, we could use this model to already predict on the tweets what it thought that the label was, and then by using this confidence we could prioritize the tweets of which this model is less certain. So this way we focus on the tweets that are the hardest to classify, and we have the most value from only a little amount of tweets. Then this annotation process started. So we worked together with 4 people who annotated the 50,000 tweets, and we also decided to have some tweets, a part of the data set, labeled by multiple people, so that we could understand how people were reacting to this, if they even agreed among each other, if maybe some annotators were less good than others. So that's why we asked for this, and all they had to do was read the tweets, then attach a label to it. And if it was not in Dutch, or if it was not understandable, often there might be tweets that are in West Flemish, which is a dialect, that are really not at all understandable. So in this case, they could discard it, but also often there were tweets in other languages or only one word that had no meaning. So we removed those. And we also add a flag button. So people, when they were not sure about the sentiment, they could flag it. So that later we could review these tweets that the annotators themselves were not sure about. At the start of this annotation process, we really wanted to make sure that everyone who annotated, that it was of great quality and that everyone did it in the same way, because otherwise we might confuse the model. If someone would say one kind of tweet is positive and someone else says it's negative, yeah, it's confusing and it will not do good for the accuracy of the model. So that's why we started with defining a sentiment. So in some cases it can be very easy. For example, this chocolate is delicious. It's an explicit sentiment. It's not up for debate. This is just a positive one. But there are also some implicit messages, like my iPhone broke in just a week. This just means that it's like something really negative. But if someone would write, my iPhone broke in a week, okay, I could think it's bad because you don't like that your iPhone is broken, but actually it's just a factual statement. My iPhone broke. There is no actual sentiment in it. So that's why we wanted to really define this. So there are two ways to annotate. So the first one is the sentiment that the reader experiences when reading the tweet. So in this case, this could be the one, my iPhone broke in a week, could be because I experience it as negative. We could label it as negative. But the problem with this is that it might differentiate a lot among different annotators. And then the other one is the sentiment that you think the author intended, but this can be very difficult because you cannot look in the head of someone who wrote a tweet. So it can be ambiguous when the intentions are not clear. But one example is that the Trump wins crucial swing state, it should be neutral. The Trump wins crucial swing state with a happy emoticon is positive, and with a negative emoticon is negative, because we can infer the emotion of the person writing it. But all factual statements should be labeled as neutral. So if this would have been my iPhone broke in a week, it should be neutral because there is no emotion attached to it. Yeah, we defined the whole process. I'm not going to go through this. I just wanted to show you that we really made like a whole decision tree that people had to go through to decide if a tweet is neutral or positive or not, and to discard, when to discard it and when to flag it. So we really spent a lot of time in defining this and understanding how we could make sure that the quality was as good as possible, but it was really difficult. So what we learned is that Twitter is a really difficult source to label. There are all kinds of messages, and they are not the exception. They are almost the rule. They are really difficult to understand what their sentiment actually is. So for example, there are a lot of dubious messages. So this can be an example. I want to go back to snowboarding. It's something positive because you want to go back to this vacation, I'm assuming. So it was a good vacation, but in another way it's negative because you are not happy with the environment in where you're in right now, because you want to go back to the snowboarding. Another example that we got often is maybe why is it that I'm so often so happy but other times so sad? It really has two explicit sentiments. How do you label this? Then there is the sports. There are a lot of tweets about sports, and for these it's really difficult to do the thing that we talked about that you need a clear sentiment in order to label it positive or negative, because often there are a lot of article headlines that maybe say after 3 points behind they managed to still win. yeah, it's positive, but it's just a factual statement. So it was really difficult to make sure that everyone labeled this in the same way. The same for advertisement. It can be, when it's clear advertisement, it's often very positive, but it's not really the sentiment of a person. It's just someone trying to convince you that it's something good. So there were also a lot of problems with this. And then, yeah, topics like politics, but it can also be other things where you really have to understand the political context often to understand if someone is being positive, negative, or even sarcastic. So this would also result in people labeling something different because someone might not understand it and then just say, okay, I think it's neutral. And as someone that really understands what is going on in this tweet, he or she will say, I think this is definitely negative. It's a sarcastic kind of message. So this brings me to the evaluation. So in the end, after the labeling, we trained the model with our labeled data set, and we kept 3,000 tweets as a test data set, which the model had not seen before, and we wanted to check what the performance was. So this is the confusion matrix that we retrieved. So the columns are the true values and the rows are the predicted values. So this means that from the actual negative labeled tweets, that's 37% were also labeled negative, and that 15% was neutral and 11% positive. So what we like to see is, of course, that this is as high as possible because these are the rightly predicted labels. And we see that there is in general about 70% accuracy, and that there is also no specific choice as it comes to the other classes, because they all are around 15%, maybe here a little bit lower. So this means that when the model does not know, it really has no idea. You would think that maybe there would be more neutral and then even less positive, because you would think that the difference between negative and positive is bigger than between, for example, negative and neutral, but this is not the case, or at least not in a very big matter. So at first we were not so happy with these results because 75%, it's not that high. It should be higher. But then we had a look at our labeled data, and we saw that not even the annotators themselves agreed on the sentiment very often. So if you look at the tweets that were annotated by multiple people, so A, C, and B, they are three annotators in this case, we see that A and C, they only agreed with each other on a sentiment in 61% of the cases. Only 50% of the cases, the three of them all agreed. And you see B and C, they are in higher agreement. They agreed 75% of the time. And what is even more interesting is that some people even labeled the same tweets multiple times. And in this case, there was even also 90% agreement. So this means that if you ask someone to label a tweet today and you ask this person to label the same tweet tomorrow, only in 90% of the cases, he or she will give the same sentiment to it. So this really highlights how difficult it is to define the sentiment of a tweet, often because you miss context, or you don't, it's ambiguous. It can have two. So in light of this, the actual agreement was not that bad. So we decided not to talk about accuracy in this matrix, but about agreement. So in how many of the cases does the labeling agree with the model, actually? And if you look at this, this agreement is higher than the pairwise annotator agreement. So the model is agreeing more than the annotators among themselves. So if you look at it this way, I don't think it will be easy to make this percentage higher, except if you maybe do some extra work on the data, maybe discard some more tweets or things like that, but otherwise it will be very difficult. Okay, as I already explained, the next thing that we wanted to do was to automate the flow. So we wanted to to extract the tweets from Twitter and to store them, and then represent them in our dashboard. At first we wanted to have an hourly representation of the statistics, but in the end we did not do it like this, but I will come back to that in a minute. And then also there was a preference for an explainable solution. So we wanted to know why some tweet was given a positive, a negative, or a neutral sentiment. And then, of course, the sentiment analysis model, but this one we already discussed. So this is the architecture that we came up with. So the Twitter API, it's an API that actually exists that you can subscribe on, by which you can extract some tweets. Then we set up an AWS batch instance that scheduled the hours on which we wanted to retrieve these tweets, and then also activates the Docker where the model is running in. Once this model is activated, it will get the tweets. It will calculate the predictions of the sentiment. We will store the tweet into the AWS S3, and we will store the data about the sentiment and things like that in a DynamoDB. And then once our dashboard was made in Vue.js, and once this is opened and someone wants to gives a request about the data that someone wants to see, this Lambda is activated to retrieve the data from the sources to show it to the person. I'm not going to go in full data, but so this Twitter API, if you assume that there are 31 days in a month, then this means that you only can have 16 queries of 500 tweets per day. So this means a total of 8,000, but you have to get them in 16 queries. So this is also something that we had to keep in mind while building this thing. So we did some research, and we saw from an article that this is the general distribution of tweets. So this means that at between 10 and 11 people tweet a lot, and then of course during the night hours there are less tweets. So we wanted to sample the tweets according to this distribution, because we don't only want the morning tweeters, we also want the night or the day evening tweeters, because they might have different sentiments. It might be that people with more negative sentiment might be tweeting in the evening, I don't know, but we wanted to make sure that everyone was represented in our data. So by making sure that we defined a strategy to retrieve the tweets that made sure that we had tweets according to this this distribution. So our batch was set up in this way that we can retrieve the tweets. So that's something like this is what we retrieved in the end. And then as a last step, we also worked on this explainable solution. So we used a tool for this that was already prepared up front. So the language interpretability tool, it gives, you can click on different tweets. You can see the label that it gets and also the distribution of the labels. So you can see how confident it is about a different class. You can also have a look at the embedding space, how the tweets are related to each other in this space, and you can also see to which words the model pays most attention. So this means that these words are most important to determine the actual sentiment. Okay, so now I will show you the demo of our actual tool. So we built two panes on it. So the first one is this one. It shows how many tweets that there were in the period that you defined. Yeah, it's in Dutch, but so here you can define your period. So this is the year, the month, past week, and here you can choose the period that you prefer if you want to see another period. And then here you see the number of tweets. So this is the number of positive, number of neutral, and the number of negative tweets. And this is the proportion of the positive tweets compared to the number of positive and negative tweets. There are more negative tweets in general than positive tweets, so this is often under half, and you can see some peaks. So this is what in other things that we have read, other literature about sentiment models, we already saw that in general, also in other countries or for other languages, there are spikes at Christmas and at New Year. So this is also giving us a confirmation that our model is working, because we also have the spike around Christmas and the spike around New Year. And then there is a second panel where you can see the different sentiments next to each other. So there is the positive sentiment in green, the neutral one in gray, and then in purple the negative one. So as you see, the negative ones are the most present. This is for March, and you can see that were actually two peaks for the negative ones. If you look at this one, this is interesting because it's on the 24th, as you can see here, on the 24th of March, and this was the day that the government announced some new restrictions, that the shops were closing again, and people could not be outside with more than 4 people. So you see a peak of people that are not happy and are messaging in a negative way. There is also another peak, which is actually on the International Women's Day, where there are negative tweets. This is something that I'm not sure of. It's just something that I thought of myself by looking at the tweets that we saw generally on this day. But it's because there are a lot of messages like, we are still fighting for something specific, and because it has like the word fighting or we are not there yet, it has more negative than positive sentiment. So I think that's why this peak is here. But in this dashboard, we did not do any interpretations of the model, so I cannot see it directly. And then we also see a peak here, which I think is because of the nice weather and people are more happy to go outside. But also not sure about this. This is just my interpretation. So we did this research and we had some results out of it, but there are definitely some things that we still believe that you could do in the future to improve this more. So one thing is doing a labeling action with multiple annotators. So really making sure that the same tweet is annotated by a lot of people over and over again. And if you then take the mean or majority voting of these annotators, it will give you more, a more generalized representation of a sentiment of a tweet. So I believe that this will really improve the model. So this means doing another labeling action. Then something that I think can be really relevant is adding this dashboard with trending hashtags. Because as you saw from this, we can see the spikes, but we don't really understand why are they there? Where are they coming from? So if you could just click this, and here you would have like a an overview of hashtags, you could directly see, oh, these are the most important hashtags on this peak or this peak. You could see the positive ones or the negative ones. Can be really interesting. And then also add calendar tags to the time. Here, it's not that easy to see that this is actually Christmas and that this is New Year. It could be nice if there would be just like a tag Christmas, New Year, or even here International Women's Day. So that's what I would propose as possible things to invest in the future. And this actually brings me at the end of my presentation. Are there any questions or things that I went over too fast that you would like to re-see or something like that?
Thank you for the amazing session, Shoera. At the moment, we do not have any doubts. I think we can wait for a minute or two to see if anyone who has a doubt can put that up.
Okay, thank you.
We have a doubt from Maya. How did you do the geocoding of the tweets to know they are Flemish? Was it based on the location of the tweet or the language label? You're on mute, Shoera.
So that's why we actually needed that's why we actually needed the premium version of the Twitter API, because this information is available in the premium version. So it's on both. So we did check before which language it was, and also the geo filter, but we saw that this geo filter, it's not filled in a lot of times. So then there we also looked at just the profile of the person that tweeted, where he or she is from.
Okay, great. We also have a question from Nishant, who asks what AWS Lambda is used for and why Dynamo and AWS are separated.
Can you repeat the second half?
Why Dynamo and AWS are separated?
So indeed, this Lambda, it's because it's only it's only activated when we are using the Vue.js dashboard. Otherwise, you would have some instance that is running all the time, and you also have to pay for it all the time. And because at the moment it's only for research, it's not used at all the time. So it's not really valuable to have it running all the time. So that's the AWS question, the Lambda question. And then the Dynamo. Good question, because we wanted to store just the full tweets. We wanted to store them to make sure that if we would ever do this again, that we don't have to go to this Twitter API again. But I don't think this is this is used because we don't show, we only are interested in the numbers, so not in the actual tweets. So that's why we are not interested in having this information only in how many positives were there, how many negatives.
Okay. We have a question from Majdoub. Is there a way to define strictly annotation rules to get more consistent results if that's not already the case? Or the only way is getting more annotators?
Yeah, please, could you
Yeah. Is there a way to define strictly the annotation rules to get more consistent results if that's not already the case? Or the only way
Yeah.
is getting more annotators?
So I do agree. Maybe you could make them more strict because there are these classes that I already talked about. So you had the clear advertisement, the clear sports. Maybe we should have more clear rules for these specific topics. But I think in the end, it's because our tree, I did not show you everything. In the end, we had made so many rules that we had more than one full document of rules. And if you want to train people to actually follow these rules, it's also very difficult and it takes a lot of time. And because of this, I think it's even easier. It's less work to have 10 people doing the same tweets than defining all these rules, because it's just, yeah, so difficult.
Yeah, that makes sense. Another question from the same learner. For explainability, do you deal with it locally per individual tweet, or do you have more general stats?
No, so the explainability is now only locally. It's not. It's just to have an idea of why we are making some predictions. This is also definitely something that could be interesting for the future to also add it in the dashboard and incorporate it within the tool. But right now it's yeah, completely separate.
Okay. I think we don't have any more questions. Pretty much all of them are covered. Okay, there's one more from Maya. You've highlighted how difficult it is to categorize tweets even with only 3 categories. There is a lot of work there's a lot work that categorizes tweets using more detailed emotions like anger, joy, disgust, etc. Do you think that work is doable?
I think it's definitely doable, and it might even increase the performance, because now, like, a lot of problems that we have is because tweets that are sarcastic, they can come off, they can seem positive but are actually meant negative, and maybe it would improve the performance if you could actually label them as sarcastic. So I think it's doable. The problem is then you also need to have these rules for all the other emotions. So I think the labeling action will take more time and will be more difficult. But besides that, I think it's yeah, possible.
Mm-hmm. Yeah, I think we've covered all the doubts now. Thank you so much, Shura, for taking this session
Okay.
and for taking out your time to educate us about the like. I'm so sorry for the noise. About the sentiment analysis tool for Dutch. And
Okay.
thank you to everyone who was able to join and who asked such insightful questions from us. And yeah, I think we can end the session now. Thank you so much.
Okay.
Bye bye.
Thank you. Bye.